Yes. Good afternoon to you all. We are on calculus tutorial 6, which is still on integration. So we want to look at certain differential equations and then we solve them as such. So given that we have to solve this differential equation, we have dy dx is equal to 5x squared plus cos 3x. This is what we have. How do you solve this? So we first say that dy is equal to 5x squared plus cos 3x. Okay, then dx. So we can integrate both sides by saying that dy, then here is what? 5x squared plus cos 3x dx. Dx. So sorry. So over here, we want to integrate both sides. So in integrating both sides, we are going to have a very, very nice expression that will definitely. So we say that y is equal to 5x what? 3 over 3. Plus, if you integrate cos, you get sine. So we have what? Here we are going to have sine 3x over 3 plus c. Remember when we were doing the integration, we said that we differentiate this, then it will come down like that. So that is that. Okay, it is very, very straightforward. Okay, now let's look at another one. We say we have to solve this, and we have to solve this. We have x dy is equal to 3 minus 2x squared. Once again, what do you have? You have dy dx is equal to, you are using the 3 minus 2x squared over x. Okay. So what do you do? I'm having my dy dx, okay, is equal to 3 over x minus 2x. X divides, this is what you're having now. Okay. Now, so I'll just have dy is equal to 3 over x minus 2x dx. So integrating both sides, I have dy integral is equal to integral 3 over x minus 2x dx. So here I'll get y here, and here becomes, anytime you're having 1 over x, if you integrate, you're going to get ln x. So here becomes what? 3 ln x. Then here's already 1, so minus, yes, 1, so it becomes what? S squared. Do you understand why? There's 1 here, so plus 1. Okay. Then plus c. After I do it, I always check whether what I worked, it is still in line. And it is correct here, so it means everything is correct. Exactly. I'm repeating. Look at how I did it. First, I moved this one to divide through, and I got this. After that, I integrated both sides, and this is what we got. Exactly. I hope you are okay. We can continue. Now, let me see if I can get another example for you. And if you are going to get about 2 or 3 examples under this, it will be okay. Then the rest you go and try your hands on. Okay. Now, let me see. Okay, another one is here. It says dy dx is equal to, here was x, we have 5x cubed plus 4. So we have what? Dy dx is equal to, as we divide this, we have what? 5s squared plus 4 over x. So dy is equal to what? 5x squared plus 4 over x dx. So I can decide to integrate both sides. So what is y? Y is equal to 5x 3 over 3 plus 4 ln x, then plus c. Anytime it is divided, it is ln that, okay? Let's see if I can get another example for you. All right. Okay. So, let's see another example. If I have I'm trying to see if I will get. Okay. Dy dx is equal to 4. So here, dy dx is equal to what? 4 over ex power x. So dy dx is equal to 4 e negative x, right? So if dy is equal to 4e negative x dx, I can decide to integrate both sides like this. So what happens? We are integrating, okay? So we have y is equal to what? I think over here something needs to be done. What is supposed to be done is that the e negative, this one becomes negative, so we are going to have 4, that's negative 4. What? E negative x plus c. That is your result. Okay. Now, after this one, you want to look at another one. But here you have to be a little bit careful. Carefully watch this example. The example is dy over dx equal to 2 plus y. What change have you noticed? Always here is x. This time here is y. And here is what? Dy dx. So we have to actually rearrange in order to get expression for dx. So I'm going to have it's going to be, if you rearrange, you are going to get dx is equal to 1 over 2 plus y dy. Yeah, I know some people will be getting a little bit confused, but that is how it is. Okay, this is what you are supposed to actually work on. I'm repeating. I'm saying here, we have the y dx here, but here instead of x, we are having y here. So you have to rearrange so that you rather work on dx. Okay, so we use the dx in our workings. So if you are having something like this, how best are you going to actually maneuver in this operation? If everything is all right, let me check it once again to make sure that what I've captured is what is here. So if that's the case, then we say that if I integrate x is going to be what? It's going to be ln 2 plus y plus c. Anytime what is here is the ln. It is 1 over 2, it is ln that. If it is, let's say, 3 over 2 plus y, that could be what? Or let's say y. It will be 3 ln 2 plus y, and so on and so forth. I'm trying to see if I'll be able to get another example that will help you. But I'm saying that here is what? Ln 2 plus y plus the constant. Okay, that is what we are having. So let me see if I'll be able to. I'm trying to get variety of examples for you. But if I'm not getting, then I will move to another aspect. There's an aspect which is called separation of variables, where I'll be working 1 or 2 examples, then we bring our tutorial to a close or to a halt. We're going to have a situation where integration by separating the x and the y variables. Okay, separation of variables. I'm trying to see if I'll be getting one. They say we have to solve the differential equation dy dx equal to 3x squared minus 2 all over 2y minus 1. Here, because of this separation of variables, that is, then the x will go with the x component, then the y will go with what? The y component. So I'm going to have 2y minus 1 in brackets dy is equal to what? 3x squared minus 2 into bracket dx. So now, how do you integrate this? You remember how we integrate this? Here becomes what? 2y squared over 2 minus y. Okay? And this one, when we do that, I think there's going to be some sort of calculation. Let me check whether I'm really on track. So, what is the original question? Yes. Okay, I'm on track. Okay, then here is what? Here is 3x 3 over 3 minus 2x plus c. So here I'm having y squared minus y is equal to x cubed minus 2x plus c. That's what I've got here, and that is what is actually I worked and I got. Is that okay? So take note of that. Is that okay? Take note of that. I think we are left with almost 2 examples. Then we bring our entire separation of variables and this tutorial to an end, so that the rest we go and then be working on them. Let me see if I'll be able to get another one so that you look at it. Now, look at this example. 1 over 1 plus y dy dx is equal to 1 plus x. Okay? Here, what are we having? Alright, we have dy here, so it's 1 over 1 plus y dy is equal to 1 plus x dx. That's what I captured here. So if you want to integrate this, it's going to be what? It's going to be ln 1 plus y, okay, is equal to, if you integrate this, we are going to get x. And if you integrate this, I've already taught you this one already. it becomes what? S squared over 2. Then plus C. Is that okay? That is basically what you're supposed to get. And you should get that simply because that's what you're supposed to get. Okay? Now, it is interesting. I'm gradually coming to an end of this interesting lesson. So please, this is differentiation by integration by what? Separation of what? Variables. Let's look at another interesting one and see how best we'll be able to handle it without any difficulty. We have 2 plus x over 1 plus y. dy dx, okay, is equal to 1. Wow. What an interesting something is this. So here, if I were you, note that this is over 1. So I can just say 1 over 1 plus 1 plus y dy. Okay. Then this one goes here and becomes 1 over. Let me just clean here. This is separation of variables. Try and get it. 2 plus x, okay, dx, correct. So over here, what are you supposed to do? What are you expecting to see? You are expecting to see something interesting. Here, I'm saying that if you are integrating something of this nature, it is just ln what? 1 plus y. Is that okay? Yes, any question? No. So that's that, okay? Is equal to ln what? 2 plus x, then plus c. Now, this is what we have got. But interestingly, anytime you're doing like, something like this, and you have ln here, sometimes this constant, we can describe it as ln A, okay? So I'm having ln 1 plus y is equal to ln what? 2 plus x plus ln A. Like this. What an interesting, oh, that is mathematics, is that okay? Ln A. We do it on condition that we have ln here and ln here. And by the principle or application of the logarithms, you know, whenever you are adding the figures attaching to the logarithm, you can just put it this way like, so here, I'm having what? Ln 1 plus y is equal to ln A into brackets, okay, 2 plus x, this application. Now, taking logarithm from both sides, this is ln and here is ln. So of course, if ln clears ln, I'm going to have what? 1 plus a y is equal to what? Ln A 2 plus x. So somebody can decide to leave it like that or continue, and that's it. So another person can also write it as y is equal to A 2 plus x minus 1. That's your answer. Now, I think we've done a lot, and on this note, I just want to say that we've covered a lot. That is, we started with the differentiation, okay? The basic differentiation, then we moved to differentiation from first principles. I'm just drawing at your attention that I cannot remember everything, but I know that unless we did something on, I'm wrapping up, okay? Unless implicit what? Functions. We spoke about it in one of the tutorials. So go through tutorial 1, 2, 3 up to 6. You see all these things I'm talking about. We also dealt with what? Differentiation from what? First principle. We did that. Then the chain rule. The chain rule. Then we deal with the product rule. We deal with the what? The quotient rule. We learned about how to integrate and differentiate equation or expression involving this, and then involving the ln, and then so many. So I think that, and then we have integrated a lot. If you are able to have time to go through all these aspects, I'm telling you, my brother and my sister, at least I know that the Calendar Man TV though it cannot solve all your mathematics problem, it will contribute to almost 60 to 70% of your success in examination. What we have done here, we're going to tackle these polynomial functions, all these functions. But I intentionally tackle this calculus because I know a lot of people need it, and a lot of people have started bringing the topic that they think we have to, handle. So wherever you are in the whole globe, whether you're in Australia, wherever you are, try as much as possible to send the message across. Don't be greedy. Make sure that your brother also enjoy what you are actually enjoying. After all, you're not paying anything. It's a matter of subscribing. So what are you supposed to subscribe? If you are in a secondary school, the moment you get it, you are in university, share it to a lot of people. But make sure that when you subscribe, press the notification button. Please, this program, as I've already spoken to you, Ashin Senior High School is a secondary school that you can go. That will help you. When you go there, you'll be seeing a lot of, the foreigners, and then the local people. And we have very good teachers that will actually be helping you to pass your examination. Is it mathematics, science, whatever it is? You have the men, you have the teachers there, the powerful teachers, and I can testify that they are very, very good people. So you can call Ashin Senior High School on 020 89 85 488. Ashin Senior High School 020 89 85 488. Just go there, and then you'll be getting more of their actual tutorial. And apart from that, I'm also saying that if you want land, litigation-free land, where these people will not be chasing you with machete and others, then of course there's only one company I can recommend to you. It is no other company than Forever Construction and Consultants Limited. That is the place where you build your land, you build your house, whatever it is. You don't have any problem at all. Forever Construction and Consultants Limited, well, please just write this number. Take your time and write this number and call them immediately after you hear. When you call them, tell them that you saw this thing on the Calendar Man TV, and they say they will review the price for the moment you mention to them that this is where you heard it from. Get a piece of land, get a piano. It's not a good day that your landlord will just be pushing you here and then you will suffer much at the end of the month. Bring the money. Meanwhile, you don't have any, but you have your own land, you can develop it and do a lot. It is a litigation-free land. Please call these numbers 050 60 128 then 20. I'm repeating 050 601 2820 Forever Construction, or 0277 44 3225. Call Forever Construction Consultants Limited. I'm reminding you that there are several topics that are on the way that will be treated. You have to be treating the quadratics. You have to be treating, I've already treated probability. We'll be treating the global mathematics, the mensuration, the trigonometry, and then the sequence and series, the matrices, and so on and so forth. A lot of topics are coming your way. Apart from that, I'm just telling you that thermodynamics and mathematics, all these areas, you'll be getting a lot of information from whatever you want. You can also send messages to us. Okay? I'm also reminding you that I have a very powerful mathematics book, that's the Calendar Man series, a very powerful math book. That if you call, you'll be able to give you a copies. And that number, that one you can call 027. That's my number, one of my numbers. 027 383 1010. 027 383 1010. A very interesting number, a number that is well to be here. 027 383 1010. Call, you can order for the Calendar Man series, a very powerful mathematics book that will help you, which I think are approved by all standards. Thank you very much for watching us. Stay tuned and subscribe. Tell your people to subscribe. Thank you.